Hi everyone, welcome to the regression analysis lecture. This is one of the subjects in the Statistical Science Study Program, Department of Mathematics, University of Indonesia. Now we are still dealing with model building. We've done with the quantitative variables and also with the qualitative variable for one predictor. That is for 2 levels, 3 levels, and how we look also at the change of baseline and the effects of changing baseline to the result. Okay, so for this session, we will focus on the two or more predictors. Both are qualitative or categorical variables. Okay, so I think that for example, this is just a hypothetical story about the problem. Let's say we have there's given a product and then we ask a person to give the score representing the preference to the product. And then we want to look at the effect of gender and the brand of the product to their kind of like preference rating given by people. So in this case, we have our variable x1 is gender, that is male and female. X2 is the brands. Here we have brand A, B, and C. Okay, so both are categorical variables. This first one, x1 with 2 levels, x2 is the categorical variable with 3 levels. Okay, so if we just look at the template of the model, okay, usually we will just have, okay, expected y equals beta naught, beta 1, x1 plus beta 2, x2. Okay, if we have x1 just like male, female, and brand is ABC, or then probably you may code this male as 1 and then female as 0, for example, and then for example brand A as 1, brand B as 2, brand C as 3, and then you write the model is like this, then it is big no, you can't do like that. Okay, so I think that in another what is it, another video about categorical variables, I already explained why you can't do something like this. Okay, so in here we need our model to be something else, that is, remember, we have categorical variable. It means that we need to create like dummy variable. So then for x1 here, okay, we still have that, and then for x2, for example, I will have x2b and x2c. Okay, so here what we have, so this is kind of like the model that we can propose. Okay, with the definition of x1, for example, I have 1 if it is male and 0 otherwise. It means that the base level, oopsie, it means that what is it? It means that the baseline or the reference for gender is that female, and then I have a definition of x to A equals 1 if brand A and 0 otherwise, and then I have the other indicator for brand. The second dummy variable for brand is that x2, oh okay, I just have x2b and x2c. So 1 if brand B, 0 otherwise, 1 if brand C, 0 otherwise. So in here we have that base level is that brand A is the reference or the base level, while in here we have female is the reference or the baseline or the base level. Okay, so with this kind of modeling, now we can try to to run the data. Okay, here I have the hypothetical data. Okay, so this is how I generate the data. I created, okay, so here we have, okay, I generate a sample size of 100 and okay, gender, and then we have that H2 as the brand. Okay, and then this is how I define or generate the Y and give some noise in here. So if you want to look at the data, it's like this. So for example, the first data point is male, giving rating to brand A, and the score is 19.96. And then for example here, number 19 is female, giving rating to brand A is 24.48. Okay, so then if we want to fit the data here, okay, fit the regression line to the data, we have something like this. Okay, so we have that this is the output, so we can just say the result here. Okay, so we have that actually how do we do the interpretation here? So because we have two levels for male and for gender, for brand, three levels. So actually we have three levels combination here. So it means that actually, we have model, okay, estimated model is that we have here, okay, I just copy and paste it here. So we have 22.87, and then x1 is male. Okay, so it's in line with our definition here, that is minus 2.69, and then for x2b is that minus 4.94, and then for x2c is that minus 2.02. Okay, so how do we do the interpretation for this thing? Okay, so we can see that, okay, 22.87, actually that is the average rating for a product given by, this is 0, x1 is 0, x2b is 0, x2c is 0, which means that this 22.87 is the average rating of a product given by females for brand A. Okay, so that's how we get it. So for brand A, we have here is that for brand A, and the rating is from here. So brand A given rating from female. Okay, while if brand A and it is okay, so brand A and then it is from the rating is given by males, so brand A, it means that all H2s are 0, and then male, so with beta 1, so here we have here minus 2.68 or 69. Okay, so we can see here that actually we can say for brand A, males ratings are tend to lower than the ratings from female. Okay, so we can say female prefers brand A rather than males. Okay, so then if we look at brand B, Okay, we'll just change it here for brand B. And if brand B and it is female, then for female, this is x1 is 0, so we have just 22.87. This one is 0, and then we have minus 4.94. Okay, if brand B and it is from male, the rating? So brand B male, this one is 1, so we have this, and then it is brand B, so we have this minus 4.94. Okay, so again we can see here, okay, the difference here minus 2.69, or here for female, we can say if we compare the female for brand A and brand B, I think that females prefer brand A compared to brand B because the rating for brand B is on average 4.94, lower than the rating for brand A if we compare within the gender. And then we also have brand C. Okay, so brand C for female, brand C for male, brand C for female, we have here 22.87, here is 0, and then for brand C is that minus 2.02. Okay, Y brand C for male 22.87 minus 2.69. Okay, this is one for male, and then brand C that is minus 2.02. Okay, so here we can see if we want to see, okay, within the same gender, either males or females, we can see that actually brand A is most preferred if we think that the higher the score is, they are showing higher preference. Then we can see that most order of preference for brand from most liked to least liked. It is, so we just compare this, okay, because this is negative means that brand B is less liked compared to brand A, the baseline, and also brand C, so it means that brand A is the most liked one, and then after that brand C, and then after that the least liked one is brand B. Okay, and then if we compare the rating based on given the same brand, okay, given the same brand, then I think that if we compare the gender, is just looking at this, we see that males tend to give lower rating than females. Okay, so we can say males tend to give lower rating than female. Okay, so that's how we do modeling using the two categorical variables with several levels. So in conclusion, actually again, for having categorical variables, actually you are having models as much as the number of the levels that you have there. So for example, like and if you have more than one categorical variables, then the combination of levels in each of the category will give you each model. So in this case, we have each model because we have two levels for the first category, that is gender, and we have three levels for the second category, that is brand. Okay, So that's our introduction for qualitative variable with two predictors. Later we will see when we need to consider to put interaction or not to put interaction term in our model.